Hello, my favorite chemistry students. This is going to be the best video of your life, and you are going to love electrochemistry. This will go fast, so I'm working on page 724 in your textbook. If you'd like to follow along, I'm going to teach you about simple voltaic cells. There are two different types. There is this type right here that has a salt bridge. And then there's this type right here that has a salt bridge that's just a porous wall. Both of these are voltaic cells. They both have oxidation and reduction things going on. So let's talk about the parts of this voltaic cell right here. What you have is pictured here, you have the anode. The anode is where oxidation takes place. So here's the reaction for what's happening in this anode right here. The copper metal is turning into a copper ion, and you're making two extra electrons, and those extra electrons travel from the negative charge over to the positive charge. So always remember, the electrons flow from the anode to the cathode in whatever voltaic cell you're working with. They always go from the anode to the cathode. Then our cathode is always where reduction takes place. And in reduction, you're always starting out with an ion in solution, and you're forming a solid. So this electrode right here is going to get larger. This electrode is going to get smaller. And it's using these electrons right here that are coming over from the copper oxidation process to carry out this half reaction. So this is what we call a half cell, and this is a half cell. The half cells are connected by a wire, which is what the electrons flow through, and it always goes from anode to cathode. Anode is always where oxidation takes place, and reduction always takes place in the cathode. I remember it red cat and ox. And whether they're losing or gaining electrons, I remember Leo, the lion, says grr. Lose electrons oxidized, gain electrons reduced. That is the grr, even though I'm spelling grr wrong, sorry. It's G-E-R, and it's not properly spelled G-R-R. So I apologize for that. If you do not like that, you can use a different acronym. So the point of the salt bridge is to connect, to complete the circuit. And the salt bridge, ironically, if you notice, does not have the same components as the rest of the half cells. So your salt bridge is going to have nitrate, because nitrate is what everything else is in here. So this is copper nitrate and silver nitrate. This is going to have salt nitrate, and the anion is always going to go towards the anode, and the cation in the salt bridge is always going to go towards the cathode. And that's where they get their names from. So the cation comes to the cathode, and the anion goes to the anode, and that's why they're named cathode and anode. That's why they're named cathode and anode. All right? So that is what is happening in all batteries. So all batteries go through this, this chemical reaction called a redox reaction. And you learned how to balance redox reactions in acidic and basic solutions in Chapter 4 earlier this year. What I'm going to teach you is, where does this number come from and how do you calculate it? So that is going to, we are going to do that by looking at this equation right here. So I am now going to page 737 in your book, and we are using this equation right here. So if we go ahead and we write down the reaction that we were just studying on page 724, let's write down our chemical formula here. Well, not chemical formula, our mathematical formula. I'm just going to write cat. All right, so this is our standard cell potential. If this is positive, that means that it is product favored at equilibrium. product favored. And to do this, we use a standard reduction potential table. They'll give you these numbers, or you'll have to solve for them if they're given all the other variables on the AP Chem test. And this table is located on page 738 in your textbook, and it looks like this. So each reaction, notice these are all reductions, has a value. So these right here love to reduce. The further you go down, the stronger it becomes oxidizing. So this one right down here is one that loves to oxidize. So the more negative it is, it's going to be oxidation. The more positive it is, the more it's going to be reduction. Okay? And the further the distance between the two, that means you're going to produce more. Your standard electron potential, your standard electrochemical potential is going to be higher. So now let's teach you how to use this with our reaction, shall we? So our reaction that we ran through our cells looked like this. We just write it out. Here's our oxidation reduction reaction. And what you're going to do is you're going to break it into half reactions. So I'm just going to write out my half reaction, and then I'm going to balance it. Oops. So this is my first one. There's my first half reaction. My second half reaction is this. So there's my second one. So now I need to think about which one is the anode and which one is the cathode. Using our mnemonic device, red, cat, and N, ox, so reduction, cathode, anode, oxidation, and then we also use our other mnemonic device. Leo the lion says grr, Leo grr, lose electrons oxidized, gain electrons reduced. I can figure out which one is the anode and cathode. So this one right here, since it's losing electrons, this is oxidized. Since it's an oxidized, this is happening in the anode. This one right here is the opposite. This one is the reduction because our electrons are in the reactants part. It's reduction, and reduction always occurs in the cathode. So now I can take this, and I know exactly where to put this number, and I can take and look up this number on the chart, and I know exactly where to find that number. So let's look up the numbers on the chart and write them down. So my first number that I have to look up is reduction. So I'm going to look for silver. And you can see silver is right here. And it's 0.779. So I'm going to write that down. Silver is my cathode. So I'm going to write E0 equals positive 0.799. Then I'm going to look up my oxidation. Now notice this is oxidation, so I'm going to look for the reduction one, but since it's being oxidized, I know that it's going to be down here. So copper is right here, and I write that number down. So it is 0.337. Oops, that's not a plus, that is a minus. Notice I forgot to put the minus there. Okay, and then when you add them together, we're going to get the voltage. This is the voltage on your multimeter. So this is what your, this is the voltage of your battery. So this battery that we made will make 0.44 volts. And that is how you do a standard electron potential problem. So it's that easy. You break it into half reactions. The key thing is to remember these things. Then you use that to figure it out. You look the numbers up on the chart and you just simply do a subtraction problem and you're done. And that's it. And you can do that. That will not be hard at all.